In this lesson we're going to cover even and odd functions. Now the lesson right before this one we talked about reflections. There are special types of reflections. So if we've got a graph that looks like this, for example, where it is a reflection across the y-axis like that, we're going to call that an even function. And this guy right here, we'll just say that this is y equals x squared. So that's our quintessential even function. So what about our odd? Oh, that's totally not straight. It's a little bit better. An odd function might look like something like this. Go through the origin and curve down. This will be our odd function, and this is our reflection across the origin. We'll call this guy y equals x cubed. So this is going to be our quintessential odd function. So if you look at the exponents, that's what I like to look at, is at the exponents. So the exponents really give a clue as to what this is. So with the even function, our parabola at x squared, the exponent is 2. That's our even exponent. So in even functions, all of our exponents have to be even. Conversely, if it's an odd function, all of our exponents, like y equals x cubed, will be odd. We'll look at some of that later, but that's the quick trick for me, is just identifying the exponents, seeing if all of the exponents are even or if all the exponents are odd, and if neither of them are, then it's neither an even nor odd function. That's a really quick and easy way to do it. But let's talk about what mathematically we're looking for, especially on the test. Let's say we're looking at an even function. If we go over a certain distance, x, right here, we crawled along, it'll have an f value, a function value, or a y value of f of x. If we went backwards, so that instead of going to the x value, we go to the negative x value, the same distance, and we come up the graph, we would get an f of negative x. When we plugged in our negative x value, we got a different y function. So for an even function, you should see that these guys are the same. So for an even function, our f of x will equal our f of negative x. All that means is that if I plug in an x value, you get a y, the negative x value will also give you the same thing. We'll look at a chart later to show that. The other way of doing this, if I had an odd function, if I went over a distance x and jumped up to my f of x, if I had instead gone back to negative x and I got an f of negative x, they're not the same anymore. In fact, they're exactly the opposite. They're negatives of each other. So for an odd function, our f of x will equal the negative f of negative x. So that's some new notation. It's a little overwhelming at first, but all it means is graphically an even function will have the same y values if you use the negative x, as opposed to an odd function will have the negative y values if you use the negative x. Okay, so let's look at some of our examples and just look graphically to see. So you see for our even function, it's a reflection across the y-axis. It's got to be a perfect reflection. The odd is a perfect reflection across the origin. So this example 1, is that a reflection across the y-axis, the origin, or neither? Well, all of these points are perfectly reflected across, that was a terrible line. So it's a reflection, a reflection, a reflection. So this is a reflection across the y-axis. That means that this guy is even. We look at example 2. Now they're trying to see if you understand what's going on. This is, sure, that's a reflection. This is, not really. And it's, I mean, that point is definitely not there. Is it a reflection across the origin? Well, if it was a reflection across the origin, that would mean that if I went here, I'd have a point there. So right here, I would expect a point there. This is neither an even nor odd. This is just a function that has no specific even or odd characteristics. This is looking almost identical to our x cubed, such that if I go some x value over, I get a y there, but if I went to the negative, I get the negative y. This would be our odd function. Okay, so remember, f of x equals f of negative x for evens, and for odds, f of x equals the negative f of negative x. Let's go down a little bit more to just some function values. And this is where that tip helps before. Okay, so let's just look at our exponents. So we saw graphically how we can distinguish even and odd functions. What about mathematically? If we're just looking at the algebraic formula. Okay, what's the exponents there? The exponent there is 2. Okay, that's even. What about this one right here? Well, that guy still has an exponent, but it's x to the 0, right? Any number to the 0 power, or any variable to the 0 power, is going to be 1. So this kind of has an implied x to the 0. So 2 is even, and 0 is also even. This guy would be even. That's the fast way to do it. If you wanted to check it with a table, you would say, well, you know what? Well, we're going to do the table in a bit. This is the quick, easy way. That's just how I prefer you understand it. Right here, if I've got this is a right there, odd. This guy right there, 1 is odd. All of our exponents are odd. Therefore, we've got an odd function. This one right here, okay, I've got an even, I've got an odd. I have an even and odd right off the bat. It's neither. Now again, this is going to be x to the 0, right? So if I could try to trick you, I could try to say x squared. Oh no, let's even do it like this. Let's do x cubed plus 3. So a lot of students would inherently say, oh, that's definitely odd because that's a cube, which is odd, and this has no variable. Remember that this is an implied x to the 0 because anything to the 0 power is 1. So this is odd, this is even, that means this guy would be neither. So you got to be aware of certain tricks that I'll try to throw at you on the test. Always be aware of what you could potentially see on a test. So let's go to that table that I was talking about before. How to plug these in. Remember, if it's an even function, we're going to have our f of x being equivalent to our f of negative x. But if it's odd, we're going to have an f of x equaling the negative f of negative x. Okay, so what does that mean? Well, let's plug the values into our formula. We've got this formula right here, this x squared plus 1. So if I plug in 1 into f of x, 1 squared is 1 plus 1 is 2. If I plug that into, instead of using x, I'm going to use negative x. So negative x would be negative 1. If I plug negative 1 in, negative 1 squared is 1 plus 1 is 2. Now I'll take this value and I'll just make it negative because this is saying just take this y value, this f of negative x, and make it negative. So this is negative 2. Here I plug in 2. 2 squared, 4 plus 1 is 5. Let's plug in instead negative 2. Negative 2 squared is 4 plus 1 is 5. And then this guy becomes that. If you're starting to see a pattern, you should be able to identify this. So let's plug in 3. 3 squared is 9 plus 1 would be 10. If I plugged in negative 3 squared is 9 plus 1 is 10. This is negative there. If I plugged in negative 1 squared is 1 plus 1 is 2. if I plug in the negative of this, which is just 1, f of 1 is 1 squared, which is 1, plus 1 is 2. And then I take the negative of that. So, and then finally let's do the 2. So if I plug in negative 2 squared is 4, plus 1 is 5. If I plug in the negative of negative 2, which is 2, so I'm going to take this guy and plug him into there, so this becomes 2 squared, which is 4, plus 1 is 5, and then the negative of that would be negative 5. Okay, so looking at this pattern, we have to ask ourselves, wait a second, if it's even, our f of x will equal our f of negative x. If it's odd, our f of x will equal our negative f of negative x. If you look at this, the f of x is matching our f of negative x, which means that this guy is an even function. Now if you look at our function itself, our little trick before was just identify the powers. So this guy is an exponent of 2, this guy is an implied exponent of 0. Those are both even, so it's even. So that's the way to identify it based off of graphs, based off of the algebraic formulas, and also by plugging in values, how we identify even and odd functions.